Welcome back to the Kodey Podcast. I'm Kieran, your host, and today we're diving deep into the practical world of deploying machine learning models. Now, if you've ever finished training a model and thought, okay, what's next? This episode is for you. We're talking about the tools, the techniques, and the platforms that people are actually using to take their models from a laptop into the real world. Think Flask, Databricks, MLflow, and more. So grab a coffee, settle in, and let's get into it. All right, let's start with a tool that's often the developer's first stop for deploying a machine learning model: Flask. If you've worked with Python, you've probably heard of Flask. It's a super lightweight web framework that lets you spin up a simple API in no time. Here's how it works. You take your trained model, maybe it's a scikit-learn classifier, a TensorFlow model, or something from PyTorch, and save it to disk. Then, with Flask, you write a little Python script that loads the model and sets up an endpoint. When someone sends data to that endpoint, your model processes it and spits back a prediction. Simple, right? For example, let's say you've trained a sentiment analysis model. With Flask, you could set up a predict endpoint where someone sends in a piece of text like, "I love this podcast," and the model replies, "Positive." It's like your model becomes its own little machine learning hotline. What makes Flask great is that it's easy to use and you have total control. And this is a big but, Flask is really best for small scale setups. If you're expecting thousands of users or you need super fast predictions, Flask might struggle. It's like building a sandcastle. Fun and functional, but not something you'd trust in a storm. Now, if you need something more robust, you might turn to Databricks. This is a completely different beast. Databricks is a cloud-based platform that's all about big data and machine learning. It's built on Apache Spark, so it's designed to handle massive data sets and high-performance computations. What's cool about Databricks is that it's an end-to-end platform. You can do everything from data preparation to model training to deployment, all in one place. Imagine you're working on a churn prediction model for a telecom company, and you've got terabytes of customer data to sift through. Databricks lets you clean and process that data in distributed clusters, train your model at scale, and then deploy it directly within the platform. It even integrates with libraries like TensorFlow, PyTorch, and scikit-learn. And the best part, Databricks makes collaboration easier. Teams can share notebooks and pipelines, which is a lifesaver when you're working with a group of data scientists and engineers. It's like the Swiss Army knife of machine learning platforms. But Databricks isn't necessarily the go-to for every project. It shines in enterprise settings where scale and collaboration are key. But if you're working on a smaller project or want more control over the deployment pipeline, you might not need all that overhead. This brings me to one of my favorite tools, MLflow. MLflow often flies under the radar, but once you discover it, you wonder how you lived without it. It's an open source platform for managing the lifecycle of machine learning projects. And when I say lifecycle, I mean everything: experimentation, reproducibility, and of course, deployment. Let's say you're training a bunch of models, tweaking hyperparameters, and logging results. With MLflow, you can track all those experiments in one place. It's like having a journal that remembers every little change you made. But the magic really happens when it comes to deployment. MLflow lets you package your model in a standardized format so you can deploy it anywhere, whether it's on a local server, in the cloud, or even as a Docker container. And get this, MLflow integrates seamlessly with Flask, Databricks, Kubernetes, and all the big cloud providers. It's like the glue that holds your deployment pipeline together. For instance, picture this. You've trained a fraud detection model in scikit-learn, and now you want to deploy it as a REST API. With MLflow, you can just register the model, spin up an API server, and boom, it's live. The kicker is that it also tracks your model versions. So if you update the model later, you don't have to worry about breaking your deployment. Everything is version controlled, which is a lifesaver when you're dealing with production systems. We will get back to the podcast in just a second. This is just a note from me that if you want to learn how to get hands-on with data, you can find courses on Python, Apache Spark, and more at kodey.co.uk. Let's not forget about Docker, another heavy hitter in this space. Docker isn't specific to machine learning, but it's one of the most useful tools you can have in your deployment arsenal. If you're not familiar, Docker lets you package up your model, your code, your dependencies, and even your environment into a little virtual container. Think of it like a lunchbox for your app. Everything it needs to run is neatly packed inside. This makes it super easy to deploy your model on any system, whether it's your local machine, a cloud server, or even a Kubernetes cluster. Here's an example of how you might use Docker. Say you've trained a computer vision model in TensorFlow and you're deploying it with Flask. You can create a Docker file that specifies all the dependencies, Python, Flask, TensorFlow, and whatever else you need. Then you build the Docker image and deploy it wherever you want. What's great about Docker is that it eliminates the classic "it works on my machine" problem. If it works in your container, it'll work anywhere. Now, I know what you're thinking. This all sounds great, but what about scaling? What happens when your app goes viral and suddenly you're getting hit with thousands of requests per second? That's where tools like Kubernetes and cloud platforms like AWS SageMaker come in. Kubernetes is a container orchestration tool that helps you manage and scale your Docker containers. You can deploy multiple instances of your model across a cluster, balance the load, and even handle automatic failovers. It's like having a team of robot chefs in your kitchen, each cooking up predictions in perfect harmony. AWS. SageMaker, on the other hand, is a fully managed service for machine learning. It takes care of everything: training, tuning, and deploying your models, so you can focus on the fun stuff. You upload your data, train your model using SageMaker's built-in algorithms or your own custom code, and then deploy it as a scalable endpoint. It's ideal for developers who want to get up and running quickly without worrying about the nitty-gritty of infrastructure. But here's the thing, there's no one-size-fits-all solution. The tools you choose depend on your specific use case. If you're building a quick prototype or working on a side project, Flask and Docker might be all you need. If you're part of a large team handling complex data pipelines, Databricks and MLflow can make your life a lot easier. And if you're scaling to millions of users, Kubernetes or SageMaker are probably the way to go. So to sum it up, deploying machine learning models is all about finding the right balance. You want a stack that fits your needs, your team, and your budget. It's an exciting process because it's where all the hard work you put into training your model starts to pay off. Whether you're using Flask to spin up a quick API, leveraging the power of Databricks for big data, or tapping into MLflow to streamline your workflow, the tools are there. And the best part, once your model is deployed, it's out there making an impact, whether it's recommending products, detecting fraud, or just helping someone find a podcast they'll love. That's all for today's episode of the Kodey Podcast. I'm Kieran, and I hope this gave you some insights into the world of ML deployment. If you liked what you heard, hit subscribe and leave a review. And as always, if you have questions or topics you want me to cover, shoot me a message. Until next time, keep building, keep deploying, and keep pushing the boundaries of what's possible. See you soon.